We're about to fly on an Airbus A380, the biggest commercial plane in the world. It's so big that most airports can't accommodate the size of it.
The aviation world is buzzing. Airbus, the European aerospace titan, is reportedly plotting something massive, something that could shift the entire balance of power in commercial aviation. While Boeing scrambles to recover from years of setbacks, whispers are growing louder about a bold new aircraft that might just redefine what a wide-body jet can be.
As you rightly said, plenty of uncertainties and difficulties, but also some mega trends, more and more people traveling, very strong demand for air travel.
And if the rumors are true, this could be the opening move in a new era of flight. So what exactly is Airbus planning, and why does it matter so much right now? The fall of the A380 and the gap it left behind. When Airbus unveiled the A380 in the early 2000s, it was supposed to be the future. A double-decker giant designed to dominate high-density routes between the world's busiest hubs. Airlines and passengers alike marveled at its size, luxury, and engineering prowess. But admiration doesn't always translate into profit. The A380 was impressive, sure, but it was also expensive to operate, difficult to fill, and limited in where it could actually fly. Only 144 airports worldwide had the infrastructure to handle it. That's a shockingly small number when you consider how many destinations airlines need to serve. Operational flexibility became a nightmare. Airlines couldn't just slot the A380 into their networks. They had to build entire strategies around it, and as fuel prices fluctuated and passenger demand shifted, that rigidity became a liability. The industry was also changing. The hub-to-hub model that the A380 was designed for was giving way to point-to-point travel. Passengers wanted direct flights, not layovers in massive hubs. Suddenly, smaller, more efficient twin-engine jets like the Boeing 787 and Airbus A350 made more sense. They could fly nearly as far, carry enough passengers, and do it all with better economics. By 2019, Airbus made the tough call. Production of the A380 would end. Only 251 units were ever built, far short of the break-even point. Emirates was the only airline that truly embraced it at scale, but even they couldn't keep the program alive alone. The A380's retirement left a void in Airbus's lineup, a gap between the A350 and nothing. Boeing, meanwhile, had the 777X waiting in the wings. Airbus needed an answer, but building one would require perfect timing, perfect technology, and perfect market conditions. Why airlines are demanding a new super widebody? Airlines don't ask for new aircraft unless they really need them. And right now, several of the world's largest carriers are making noise. Emirates, in particular, has been vocal. Sir Tim Clark, the airline's president, reportedly approached Airbus with a direct request for a new generation widebody. Not a refresh of the A380, but something built from the ground up with modern technology. Why the urgency? Because the jets currently in service are aging. Early models of the Boeing 707 and Airbus A330 are approaching retirement age. By the mid-2030s, hundreds of these aircraft will need replacing. Airlines are looking ahead, and they want options that fit the realities of modern aviation. That means fuel efficiency, lower emissions, operational flexibility, and passenger appeal. The old playbook doesn't work anymore. Fuel costs remain one of the largest expenses for any airline. Even a 5% improvement in fuel burn can translate into millions of dollars saved annually. Multiply that across a fleet, and the numbers become staggering. But it's not just about money. Environmental regulations are tightening. Governments and regulatory bodies are pushing for net zero emissions targets. Airlines are under pressure to adopt sustainable aviation fuel, improve efficiency, and explore alternative propulsion technologies. Any new aircraft launched today has to be ready for that future. Then there's the passenger experience. Travelers have higher expectations now. They want more space, better connectivity, quieter cabins, and smoother flights. Airlines that can offer a superior experience have a competitive edge. A next-generation widebody that checks all these boxes would be incredibly valuable. And there's one more factor: prestige. Airlines like Emirates, Singapore, and Qatar have built their brands around offering the best. They want aircraft that stand out, that passengers specifically choose to fly on. The A380 did that for a while. Now, they need something new to reclaim that magic. Boeing's struggles. Create the perfect opening. Boeing is in trouble. That's not speculation, it's reality. The company that once set the standard for commercial aviation is now fighting just to stay on course. The 707X, Boeing's answer to the next generation of wide-body travel, is more than 5 years behind schedule. It was supposed to enter service in 2020. As of now, it still hasn't been certified. Airlines that ordered the jet have been left waiting, forced to extend the life of older planes and scramble for alternatives. Emirates alone has had to spend heavily to keep aging 77s flying longer than planned. Trust is eroding. Then there's the 737 MAX saga. 2 fatal crashes, a global grounding, and years of reputational damage. Boeing has been working to rebuild confidence, but the certification process for the MAX 7 and MAX 10 variants is dragging on. Regulators are demanding more, and Boeing is under intense scrutiny. Every decision is being questioned, every delay analyzed. The company is also dealing with internal turbulence. Leadership changes, workforce issues, and mounting financial pressure have made it difficult to focus on innovation. Launching a brand new aircraft program requires stability, resources, and confidence. Boeing doesn't have much of any right now. Then came another blow in early 2025, a deadly accident involving a Boeing 787 operated by Air India.
Air India 855, clear for takeoff.
Air India Flight 855 has just taken off from runway 27 at Bombay. The plane crosses into the Arabian Sea. Suddenly, something in the cockpit goes terribly wrong.
Reignited concerns about the Dreamliner's safety and reliability. Investigations are ongoing, but the timing couldn't be worse.
वो मेरे नज़रों के सब सामने हुआ था. मेरे खुद को भी बिलीव नहीं होता कि मैं कैसे उसमें से जिंदा बाहर निकला. क्योंकि थोड़ा टाइम लिए कि तो मेरे को लगा था कि मैं भी मरने वाला हूँ.
Boeing was trying to show the world it had turned a corner. Instead, it's back in the headlines for all the wrong reasons. All of this creates a massive opening for Airbus. While Boeing is stuck playing defense, Airbus can go on offense. It can invest in new programs, court frustrated customers, and position itself as the more reliable, forward-thinking choice. And that's exactly what appears to be happening. Airbus isn't just waiting for Boeing to recover. It's pressing the advantage. What would make an A390 different this time? If Airbus is really developing a new widebody, and all signs suggest it is, the company knows it can't afford to repeat the mistakes of the A380. This time, the design philosophy has to be fundamentally different. Efficiency over size, flexibility over spectacle, future-proofing over immediate impact. Reports suggest the aircraft would be a single-deck widebody, not a double-decker. That alone is a huge shift. A single deck is lighter, simpler to maintain, and compatible with far more airports. It eliminates the infrastructure headaches that plagued the A380. Airlines could deploy this jet on a much wider range of routes without worrying about gate compatibility or passenger boarding bottlenecks. Capacity would likely sit around 400 to 450 passengers, depending on configuration. That's competitive with the Boeing 777-9, which maxes out at about 426. But capacity alone doesn't win the game anymore. Range does. And here's where things get interesting. This new jet is rumored to offer a range of up to 11,780 miles. That's enough to connect cities like New York and Sydney non-stop, or London and Auckland. It would comfortably beat the 777-9's range of around 8,383 miles, and even the 777-8's 10,046 miles. For airlines, that opens up entirely new route possibilities. Ultra-long-haul flights are becoming more popular, and passengers are willing to pay a premium for non-stop convenience. Materials matter too. Airbus has mastered the use of advanced composites with the A350. Applying those lessons here would result in a lighter, stronger airframe. Less weight means better fuel efficiency, lower emissions, and reduced wear on components. It's a win across the board. Inside, the passenger experience would be a major focus: wide cabins, large windows, advanced air filtration, and customizable lighting systems. All designed to reduce fatigue and improve comfort on flights that could last 18 hours or more. Airlines would have the flexibility to configure cabins however they want, from high-density economy layouts to ultra-luxurious first-class suites. But the real differentiator would be future readiness. This aircraft would be designed from day one to run on sustainable aviation fuel. It would also be compatible with hybrid electric systems and potentially hydrogen propulsion as those technologies mature. Airbus is betting that the next decade will bring major changes in how we power aircraft, and they want to be ready. The technology behind next-generation widebodies. Building a modern widebody isn't just about making a plane bigger or faster. It's about integrating systems and technologies that didn't exist a generation ago. Aerodynamics have improved dramatically. Computational fluid dynamics and wind tunnel testing allow engineers to optimize every curve, every surface. Winglets, for example, reduce drag and improve fuel efficiency. The A350's wings are a masterpiece of design, and any new aircraft would build on those lessons. Fly-by-wire systems, where computers interpret pilot inputs and adjust control surfaces, are now standard. They make aircraft easier to fly, safer, and more efficient. The next step is augmented intelligence, not full autonomy, but systems that assist pilots by analyzing data in real time, predicting issues, and optimizing flight paths. Sensors throughout the aircraft collect massive amounts of information: engine performance, fuel flow, structural stress, weather conditions. All of it gets fed into onboard computers that can make split-second adjustments. This reduces pilot workload and enhances safety. It also means better fuel economy and smoother flights. Connectivity is another frontier. Modern aircraft are equipped with satellite communication systems that keep passengers and crew connected at all times. That's not just for entertainment. It allows real-time data transmission between the aircraft and ground operations. Maintenance teams can monitor engine health during flight and prepare for any needed repairs before the plane even lands. Materials science plays a huge role too. Carbon fiber composites are lighter and stronger than traditional aluminum. They don't corrode, they handle stress better, and they allow for more flexible design. Airbus has been a leader in this area, and any new widebody would push those boundaries even further. Then there's the cockpit. Augmented reality displays are being tested, overlaying critical information onto a pilot's field of view. It's like having a heads-up display in a fighter jet, but for commercial aviation. These systems improve situational awareness and reduce the chance of human error. Rolls-Royce UltraFan and the engine revolution. The engine is the heart of any aircraft, and for a next-generation widebody, it has to be revolutionary. Enter the Rolls-Royce UltraFan. This engine has been in development for over a decade, and it represents a massive leap forward. UltraFan is a high-bypass turbofan, meaning it pushes more air around the engine core rather than through it. That's more efficient and quieter. The fan itself is enormous, made from lightweight composite materials. It's designed to deliver up to 25% better fuel efficiency compared to current engines. That's not a small improvement, that's a game changer. Rolls-Royce has a strong relationship with Airbus, especially after the success of the Trent XWB engine on the A350. That engine set new standards for efficiency and reliability. UltraFan builds on that foundation. It's also designed to run on 100% sustainable aviation fuel right out of the gate. That's critical as the industry moves toward net zero emissions. The engine incorporates advanced materials, including ceramic matrix composites that can withstand higher temperatures. That allows the engine to run hotter and more efficiently without compromising durability. It also features a gearbox that optimizes the speed of the fan relative to the turbine, another efficiency booster. Noise is another consideration. UltraFan is designed to be significantly quieter than previous generations. That matters for airports near populated areas and for passengers who want a more comfortable flight. Engine technology isn't just about raw power anymore. It's about balance. Power, efficiency, emissions, noise, and reliability all have to come together. UltraFan is designed to hit all those marks. If Airbus pairs this engine with a next-generation airframe, the result would be an aircraft that redefines what's possible in commercial aviation. The economics of launching a new aircraft program. Launching a new aircraft is an enormous financial gamble. Development costs can easily exceed $15 billion. That includes design, testing, certification, tooling, and setting up production lines. Airbus can't just build a cool plane and hope it sells. They need a clear path to profitability. That means securing a minimum number of orders before the program even launches. Industry estimates suggest at least 400 firm orders are needed to break even. That's a high bar, but not impossible. The A350 program reached profitability, and it faced similar challenges. The key is convincing airlines early. Launch customers get preferential pricing and delivery slots, but they also take on risk. If the aircraft is delayed or underperforms, they're stuck. So Airbus has to prove the business case is solid. That means transparent performance projections, realistic timelines, and strong supplier partnerships. Airbus also benefits from economies of scale. Many components, systems, and materials can be shared across its aircraft family. Cockpit systems from the A350 could carry over. Supply chains are already in place. That reduces costs and speeds up development. Financing is another piece of the puzzle. Airlines don't pay cash up front for aircraft. They use a mix of loans, leases, and export credit arrangements. Airbus works with financial institutions to make deals attractive. Governments also play a role. European governments have historically supported Airbus through subsidies and loans, though that's been a source of tension with the US and Boeing. Then there's the timing. Airbus needs to launch at a moment when airlines are ready to commit. Too early, and the technology isn't mature. Too late, and competitors fill the gap. Right now, with Boeing struggling and a wave of retirements looming, the timing might be perfect. But economics aren't just about Airbus. Airlines need to see value too. Lower fuel costs, better passenger appeal, and operational flexibility all translate into revenue. If the math works, orders will follow. New competitors rising from the east. For decades, the commercial aircraft market was a duopoly. Airbus and Boeing dominated, and everyone else was a distant third. That's changing. China is investing heavily in its domestic aviation industry. Comac, the state-owned manufacturer, has launched the C919, a narrow-body jet designed to compete with the 737 and A320. It's already flying with Chinese airlines. Next up is the C929, a wide-body developed in partnership with Russia. It's aimed squarely at the market Airbus and Boeing have controlled for years. Then there's the C939, an even larger widebody still in early development. These aircraft are primarily for the domestic Chinese market, which is massive and growing fast. But Comac has global ambitions. If it can prove reliability and gain international certification, it could become a serious competitor. Russia's United Aircraft Corporation is also pushing forward with the MC-21, a narrow-body jet featuring advanced aerodynamics and composite materials. Sanctions and geopolitical tensions have slowed progress, but the program continues. These new players don't have to beat Airbus and Boeing outright. They just need to carve out market share, especially in regions where cost and politics matter more than brand legacy. For Airbus, this adds urgency. The window to dominate the next generation of widebodies is narrowing. If they wait too long, they might find themselves competing not just with a recovering Boeing, but with aggressive new entrants backed by state resources. That's why acting now makes sense. Establish leadership, lock in customers, and set the technology standard before anyone else can catch up. The aviation industry is entering a new phase, one where competition is fiercer, technology is advancing faster, and the stakes are higher than ever. Airbus has a chance to lead that charge, but only if it moves decisively. So here's the bottom line. Airbus is reportedly working on something big, a next-generation widebody that could reshape the market, challenge Boeing's dominance, and set new standards for efficiency and passenger experience. The pieces are all in place. The technology is ready, the market is hungry, and Boeing is vulnerable. Whether this aircraft is called the A390 or something else, the ambition behind it is clear. Airbus isn't just responding to the competition, it's trying to define the future of flight.